Hello and welcome to Lesson 2 of Grammar Development with LFG and XLE. Just to recap what we did last time, I gave you a motivation for why I want to do deep grammar development. I showed you several application demos with computer-assisted language learning, question answering systems, and some other things. I gave you some basic information about XLE and Pargram. And I asked you to do as practical work to install XLE so that you could work with the exercises from now on, and to experiment some with the Ines Web XLE site, which contains the big Pargram grammars. So I hope you've been able to install XLE. At this point, if you haven't, go to the XLE forum and ask for help. But at this point, you really should be able to run XLE, otherwise you won't be able to follow the course. This time, I will give you some more LFG XLE basics. I'll tell you about context-free phrase structure rules, grammatical relations, also called grammatical functions in LFG, lexical entries, functional annotations, and in particular about unification, making sure everything is consistent, completeness and coherence. These are some of the very basic LFG principles that are implemented within XLE to make sure that sentences can be parsed well. I will also tell you about templates, and that will be part of your practical work to work with that. The practical work will actually involve going through the XLE walkthrough, which is part of the XLE documentation. And there'll be more details on that later on. Okay, so moving on to basic LFG. Basic LFG consists of two levels of representation. You have the constituent structure, which is basically a tree that should be familiar to anybody who's done any sort of syntax. And I've given you an example down there. So we have the simple sentence, they appear, and this consists of an NP and a VP and a sentence, an S node. Yep. And the NP just consists of a pronoun, and the VP just consists of a verb. This tree, the C structure, is annotated with functional information, functional annotations, which then result in the functional structure, the projection of the functional structure, which is shown to the right here. What the functional structure says, it's an attribute value matrix, an AVM, and it says there's a main predicate, and it's appear, and it's a subject. And there's tense present, and the subject is pred pro, person 3, and number plural. Ja. Das ist irgendwie doof. Wenn das runterkommt, for future reference, man kann hier einfach draufdrücken und dann geht es direkt wieder hoch. Also wenn Sie merken, dass es runterkommt, einfach da schnell wieder draufdrücken, dann geht es hoch und bleibt es oben. Irgendwie. Ach so, okay, das auch. So, sollen wir es dann von vorne oder von... Nee, von Wand. Okay.
Das kann ich dann rausschneiden.
Okay, dann mache ich einfach diese Folie nochmal, oder? Ja. Okay. Okay, jetzt muss man überlegen, was ich schon alles gesagt habe oder auch nicht. Okay, gucken wir das mal. Moment. Okay, so moving on now to information, basic LFG information. Basic LFG contains two levels of representation. One is the constituent structure, or the C structure, and this is a basic syntactic tree, and I've given you a representation down there. So I've given you a very, very simple sentence, they appear, and this is the tree representation, the C structure representation for that. And what you can see, it's a sentence which consists of an NP and a VP, and the NP just consists of a pronoun, and the VP just consists of a verb. So a very, very simple sentence. This C structure tree is annotated with functional annotations, which are projected into something that is called the functional structure, F structure. That is the thing shown on the right here. This is an attribute value matrix, or an AVM, and it collects together the functional information, basically dependency information about the clause. So what you have is you have a main predicate, that is appear, and that subcategorizes for a subject. This subject is has a predicate that's pro, so it's a pronoun. It's third person and it's plural. That's the information we have about the subject. And what we also have as information is that it's present tense. This is a fairly simplified F structure just to illustrate how this works. This F structure information, like I said, is collected together from the functional annotations that appear in the tree and are projected, these are these red arrows here, into this F structure. And we'll see how that works in a little bit more detail. I won't walk you through all of the details of how these equations work. You can see background on that in Mary Dalrymple's Lexical Functional Grammar book if you're interested. The XLE grammar components, and LFG XLE grammar typically contains annotated phrase structure rules, which provide you these trees that we've just seen, the C structure trees. A lexicon, which consists of verb stems and functional elements. This is assuming that you have a finite state morphological analyzer, so you don't have to have a full form lexicon. You have templates, which allow you to express generalizations. And you have a finite state morphological analyzer, which gives you all the morphological analysis. And what we also have, so the above components, the morphological analyzer, the templates, the lexicon, and the phrase structure rules, these are components that most grammars will contain. So whether you're doing HPSG or CCG, most grammars will have some of this, or tree adjoining grammars. What we in LFG also have is a version of optimality theory, OT. It's not the version that's standardly introduced in theoretical linguistics. It's a version that we've come up with ourselves, and we use it as a filter to restrict ambiguities in the parsing. We can use it to parameterize the grammar in a very simple way and for debugging purposes. And there'll be a lecture on optimality theory and how to use it within LFG. What's also possible, and which is one of the things that makes deep grammars more robust these days, is that you can include a disambiguation feature file. What this is that what you can do is you can go through large corpora, you can calculate various statistical preferences about what kinds of PPs, for example, attach to what kinds of verbs, or what kinds of verbs take which kinds of objects, and you can record all of that in this disambiguation feature file. So then if your grammar parses a clause and has 200 possible parses of this clause, you can use this disambiguation feature file to ask for the one that's most preferred, the one that what you have figured out from corpora about the language, from statistical distributions of the language, would be the most preferred analysis. And you can ask for that. So that is also in there, and that is you can include that. This is usually done in grammar development as one of the very last steps once you've written all your rules, etc. Okay, the grammar sections that we have, and these are the sections that in the small grammars that you'll be working with as part of the course. All of your grammars will have these sections, so this is important to understand. It's very basic information, but it's very important to understand. You will have a configuration section, and I'll show you an example of that, which configures the grammar. It tells you what kinds of files it has to read in, what kinds of components it has, etc. You have rules, templates, lexicon sections, where you have each of these, the C structure rules, the templates, the lexical entries. And each of these sections, the rules, templates, lexicon section, as well as the configuration section, have a version ID. This is for software development purposes, a component ID, an XLE version number, and it's terminated by 4 dashes. Okay, so here's an example. So each of these section headings, this is the heading for the rules. It says Standard English. This is what the grammar is called, and it's the rules section, and 1.0 is the version number. Okay, and here these 4 dashes, each section is terminated by 4 dashes. These 4 dashes are extremely important. If you're working with your grammar and you happen to delete those dashes, or there's only 3 dashes, your XLE will complain. It will not be able to load this grammar. And it's a mistake, or it's something that happens when you start working with XLE. You find what XLE says is very mysterious. It says there's no section end. Just remember, these 4 dashes need to be at the end of each section. Do not delete them, do not replace them by something else. The grammar will not load if you delete them, replace them, change them in any way. Okay, so here's an example of a basic configuration section. What we've got, this grammar is called Toy English, and it's the configuration section, config, and the version number is 1.0. We actually never changed this version section very much. There's information about what the root category is, in this case S. For the small grammars, we just call it S for sentence. For the larger grammars, we move towards something called root, and we'll do that as part of the course as well. There's a files entry. Here you can specify what other kinds of files might be read in. This is useful for when your grammar gets bigger and you want to have different kinds of lexica or different kinds of rules that interact with one another. The lex entries just tells you what the heading is for the lexical entries, the same for the rules, the same for the templates. What we then also have is something called governable relations. This is extremely important within LFG. These are the grammatical relations that the grammar is going to work with. These are elements that are subcategorized by predicates, and the grammar will check anything that's listed here. If a predicate subcategorizes for this, the grammar will make sure, XLE will make sure that this actually is realized, and if not, then it will crash the parse. So this is where you list the things that you want to be subcategorized for, and I'll talk more about these in a little bit. Then you have semantic functions. These tend to be adjuncts. We've also got topic in here. You can list any number here. Non-distributives is relevant for if you're trying to do coordination. We won't talk about that for a little bit. Epsilon E says that you can have an empty category, an empty node, and I'll talk about that a little bit in conjunction with imperatives and how to, it's a very useful thing to have for that. And then optimality order, this is where the OT marks can be placed and can be implemented, and I'll show you how to do that as in one of the lessons. And here, very importantly, the 4 dashes, which end this section. And these are the ones you should never touch, never delete, never change. Okay. Here is an example of what you would put into the rules section. These are annotated phrase structure rules. Basically, the way it works is that you define a category, say S, and then you define several categories that it expands into. For example, S goes to NP and VP, or S consists of a noun phrase, NP, and a verb phrase. And then what you have is you also have function annotations. So the first part, the part that's in black here, is the part that most any grammar will have. The part that's in blue here is the part that's special to LFG, where you have, these are the functional annotations, and they are done in forms of equations. So what happens here is it says, a sentence consists of a noun phrase and a verb phrase. The noun phrase, in addition, what you're giving is information. It's saying this noun phrase, this is based on English, the first noun phrase is actually a subject. So the way to read this is to say up subject equals down. And that means the up refers to the mother node, in this case the sentence. What it says is the subject of the entire sentence is what is down. Down refers to the NP, so whatever is contained in the NP is the subject of the sentence. That's how you read this. And furthermore, the subject, the case of this entity is nominative. Okay, so this is the information that's being provided by the functional annotations. It says up subject equals down. Up refers to the sentence, saying the sentence's subject is what is contained in the NP. And this has case nominative. Okay. The verb phrase just says up equals down. What that says is it says take all the information associated with the verb phrase and just push it on up to the sentence level. Whenever you see annotations like up equals down, that usually means that this part of the C structure is a head. Or whatever is contained in there is the head. Okay. So we'll see the effect of that in a little bit. Notice you have a semicolon here. You need to use this within XLE to make sure that it knows that the next rule is starting. So whenever you're done with one rule, have a semicolon, and then it knows what that the next rule is starting, or the next part of the rule. Okay, just a little note on XLE versus LFG notation. If you're going and background reading Mary Dalrymple's book, for example, you will find standard LFG notation, and the standard LFG notation For up is this up arrow. For down is this down arrow. And then there's also, we'll see this in one of the next lessons, element of a set. And the XLE notation for that is this, this hat, this exclamation mark, and a dollar sign. And the reason for that is that XLE is more ASCII conscious, so they didn't want to, while they were developing XLE, they didn't want to actually have to deal with special symbols, so they just did anything that would work within ASCII. You can also see the file basicnotation.pdf for some more correspondences between LFG notation and XLE notation. That should help you be able to read some of the theoretical background material on this versus programming with an XLE. Okay, here's another sample rule. A VP, verb phrase, and the purple here shows you how to read this, consists of a verb, which is a head, up equals down. It says whatever information is associated with me, just push it on up to the VP level. An optional object. How do we know it's optional? Well, these brackets here, they indicate optionality with an LFG, with an XLE. Just very standard, so XLE uses really standard regular expression notation for quite a bit of what it does, so optionality. Then we've seen this annotation before. This says up's object equals down, so it says the object of the thing that's up, the mother node, that's the VP in this case, is whatever is associated with the NP. And by the way, it'll have case accusative. This is how things work in English. In other languages it might work differently, but in English this is what we can say. What we've also got is a PP. It's got a star behind it. This is the Kleene star, which indicates that it's either 0 PPs or infinitely many PPs. Okay? And what is this PP, this prepositional phrase? Well, it's an adjunct. And the way this is expressed in LFG, and I'll talk more about this in one of the other lessons, is that you say whatever is associated with the PP, down, is an element of the adjunct set, of above. So it's part of the adjunct set of the VP. Okay, and that's how things are done with an LFG. What you also see here in green, these are all comments. If you want to have comments in your grammar file, use these double quotes, and then you can comment what you're doing there. You should always use comments as much as you can, even in the very, very small grammars, you should use comments. Otherwise, you tend to forget very quickly what you were experimenting with here, what you were thinking of doing there, so always use comments. They're very, very useful things. Okay, here just a little bit more on how this is all put together. So this is now the same tree that we had before. They appear, except that now I've provided you with annotations. So let's start with the lexical entries, they and appear. This is the information that is coming out of the lexicon for they and appear. They has pred pro, pronoun, third person, plural. Appear has that it is appear and that it subcategorizes for a subject, and then it's present tense. This is simplified, it's just to show you in principle how it works. So then what happens? The verb says up equals down. So it says take all this information that you've got here, pred, appear, subject, tense, present, and move it on up in the tree. This one says take all that information that's coming from the verb and move it all up in the tree. So what happens is that at the very top level of the F structure, we have this information, okay? So you have pred, appear, subject, tense, present. That's come from this lexical entry and has been propagated up into the tree here and arrives here. On the left side of the tree, you have they, pred, pro, third person, plural. Pronoun just says up equals down, says take all that information, move it on up. The NP says whatever is down there is the subject of my sentence, so put it all into a subject feature. Okay, so here's the subject feature, and we've taken everything that we knew from the pronoun and put it here. And then this thing, whatever is down there, is the subject of the sentence, so that's what it ends up being at this level, at the top level of the F structure. Okay, it's worth it when you're playing with the grammar to actually go through and look at this again, and I'll do that as part of the demo as well. Okay, So that's how the function information is collected up together and projected into the F-structure projection. Now let's look more about parts of the grammar. Let's look at the lexicon. The basic form for lexical entries is word, the kind of category it is, something called a morph code. This is very particular to XLE. You can have two types of morph codes. One is that indicates that it's a full form. This is the star that you've got there. It looks like the Kleene star, but it's not the Kleene star. This is just the same star, but it's got a different meaning. This means that we're working with a full form lexicon. And for the first few grammars, we will just work with a full form lexicon. It's painful, but it's easier to do right now, because otherwise we have to understand how to do finite state morphological analysis. And the other morph code that you could have, it's called XLE. That's what you would use if you're getting information out of the morphological analyzer. The morph code is then followed by a schemata, something like pred, walk, takes a subject, or if it's the noun version of walk, it just takes a predicate called walk. Okay? Predicates are always enclosed in these single quotes. This ensures that there will be only one version of this. It cannot unify with anything else. And it also shows that this is pointing to some kind of semantic meaning. That's the convention with an LFG. So whenever you have a pred, you need to enclose it within these single quotes to show that there's some semantic meaning here, and that there can only be one value for this. Okay. So the other entries we've got here is girl and kick. Kick is a verb, and kick in English could be either transitive, so have a subject and an object, or be intransitive, and then it would just have a subject. What you also see here is the disjunction. So this curly bracket followed by this straight line, followed by another curly bracket, that means either this part, kick subject object, or that part, kick with just a subject. And we'll be using that a lot. Okay, and here's a little entry for the. This is a functional element. We've called it a determiner, and we've just said def plus. This again is an oversimplification, but it'll do for our purposes right now. What you can also see, and you'll be asked to look at this again in the walkthrough exercise, if you have a lexical element that is of two different categories, you should not make two different entries. You should not say walk verb and have an entry there and then somewhere else in the lexicon say, oh, and walk is also a noun. What you need to do is you need to put it within one lexical entry, and the way you do it is like this. You specify the one version, have a semicolon, specify the other version. And then all lexical entries and all rules need to be closed off with a period. Okay, this is how XLE knows that the lexical entry is done with, how the rule is done with. So everything needs to end with a period. Make sure that you always end everything with a period. If you don't, it'll give you a mistake. And you'll have to fix your grammar. Okay, now we've seen subject-object a lot. And at this point, I'll tell you a little bit more about grammatical relations. They are a central component of any LFG analysis, so you'll have to know about them. They're one of these things I won't have time to tell you all the information about them. I'm going to refer you to Mary Dalrymple's chapter 2 to read about background of there. Grammatical relations, things like subject, object, indirect object, are generally referred to as grammatical functions within LFG, or abbreviated as GF. Predicates, this is not just LFG, this is general linguistics, are taken to have subcategorization frames of some version of some in some way. In XLE, this is LFG and XLE, this is done in the way that you say up subject, ups object, grammatical functions. We've seen this already. And depending on which grammatical functions are subcategorized, deciding on which grammatical functions are subcategorized is a matter of linguistic analysis. So if you're going off and working on your own language, you will have to figure out which is the subject of the sentence, which is the object, what you should call these objects, etc. So that is not something that I can help you with. That is linguistic analysis. The set of grammatical functions available in LFG is subject, object, and these are fairly standard. Then we also have object 2, or as it's more generally referred to in the theoretical literature, object theta, where the theta basically stands for some kind of role. So you could have an object goal, for example, so an indirect object, that's what they often are, or some kind of affected object. It depends on. So you could have several of these secondary types of objects, actually. The next thing is an oblique. These tend to be PPs in English that are subcategorized for things like I waited for you for hours. They could also be thetas. There could be several of these. Then we have an ex-comp and a comp. These are non-finite and finite complement clauses, and we'll have an extra lesson on those. Okay, and like I said, for more background on these, theoretical background, see Dalrymple's chapter 2. She has a very, very good discussion motivating these types of grammatical functions within LFG and generally in linguistics, and possible tests for figuring out which kinds of grammatical functions are what across languages. So do read that chapter. It's very, very useful. Okay, now a note on surface versus deep structure. These are terms in linguistics that have cropped up over and over again within LFG. You can think about that in terms of C structure versus F structure. And the empirical observation is that languages vary quite substantially in terms of word order, linear order, constituency requirements. So therefore LFG expects that C structure representations will vary substantially for languages. However, however you've done the word order or the constituency, if you have a normal transitive clause, a standard transitive clause, you should always have a subject and an object at F structure. So what LFG tries to do is tries to have F structure as a more abstract representation, as a more language universal type of representation. Okay, and an example here, Walbury versus English. Here is an example from Walbury. I'm not going to read it to you. Walbury is an Australian language. It's a very famous language within LFG. It was one of the first languages analyzed by Jane Simpson. And it has the restriction that basically the auxiliary needs to be in second position. Everything else can move around in the sentence. So this sentence it means the two small children are chasing the dog. And what you can see is you have two, this is the dual here, children are, dog, chase, small, dual. So how do you know that small and children belong together? Well, you have this case marking the ergative, and you also have the dual. So that means a speaker will know that small and children needs to be interpreted together, even though they're far away from each other in this clause. English doesn't allow this kind of stuff. English is more restrictive about discontinuous NPs and quite restrictive about word order possibilities. Walbury is quite free. So the LFG take on this is that, well, you can do whatever you like on C structure. Well, not whatever you like, but there's different generalizations. But at F structure, everything should look quite similar. And this is a slightly simplified F structure. Again, I've left out the adjunct, but basically what it's saying, well, for both of these languages, English and Walbury, what you should have as F structure is you should have a main predicate, chase, subject-object, a present tense, the subject that's a child, plural, and an object that's dog, singular. Okay? So this is the F structure analysis that you would get for both languages, even though they're very, very different in terms of their surface representation. Okay, so that's one of the basic operating principles of LFG. There's three well-formedness principles, very, very basic ones that I need to introduce here. One is consistency. Every attribute can only have one value. And what LFG is, it's a unification grammar, formalism. So what it does is it collects together different kinds of attributes and unifies them. And if it can't unify them, then the parse will fail. And I'll show you an example of that. Completeness. All grammatical functions must be present if they're listed in a subcategorization frame. So if Kik says, I need a subject and an object, then a subject and an object have to be found in the clause. And each of these grammatical functions that are subcategorized for must have a pred, so they must have a semantic feature. And this has been, in my experience, a mistake that comes along often in the beginning of grammar development, that you forget to specify a predicate for something. So watch out for that. An exception is non-thematic arguments, things like "it is raining," where the idea is that it doesn't actually have a semantic content, the "it." But we won't talk about that in this course. The last one is coherence. All grammatical functions in an F structure must be licensed by a subcharacterization frame. So you can't have spurious grammatical functions. If you have kick, subject, object, then you can't just have an oblique hanging about as well. It all has to be licensed. And we'll see examples of this with an actual grammar. Okay, now I've been telling you the whole time that we will see examples. This is the time when we're getting to the demo. I'm going to actually show you a demo, how to load a grammar into XLE, how to work with it, etc. You can download this grammar file and work along with the examples as I'm doing them, or do them again later. The grammar file is called grammar1.lfg. And I'll show you the basic LFG principles of consistency, coherence, and completeness. And I'll also show you some basic errors that are made with parsing and some tips for debugging. You will see a lot of this again when you're going through the walkthrough, but it's worth, in my experience, it's worth looking at this several times, because these errors occur again and again as you're going through, as you're beginning to understand XLE. So it's good to know about them early on. What I will also be showing you is how to use a test suite. Test suites are extremely important parts of grammar development. A test suite is a file that contains all the sentences that you're trying to parse. So what you do is you make yourself an inventory of sentences which you're trying to parse, or maybe also not trying to parse, just to make sure that your grammar is not parsing ungrammatical sentences. And you should start working with this test suite right away. It saves typing, because you don't have to type the same sentence over and over again. I'll show you that. And it keeps the grammar of what your record could do and could not do. And this is very important, because as you're expanding your grammar and making changes, you should always check to make sure that the old sentences that you could or could not parse are still working the way you wanted them to be. Okay? This is something that I've seen happening as well. You implement a grammar, 4 sentences are working fine, the next exercise comes along, or the next phase comes along, you change your grammar, you're happy the next 4 sentences work, or the next 10 sentences work, but you've forgotten about the fact that now you've changed your grammar in a way that the first 4 sentences don't work anymore. So you need to make sure that any changes you make don't break anything that you've done before. This is called regression testing. It's an extremely important part of any software development, including grammar development. You need to make sure that if you change your grammar, that you haven't killed off functionalities that you had before. Okay? The test suite used for the demo is testsuite1.lfg. You can also download this and work with it. I'll be showing you that. And again, always work with a test suite, even right at the beginning. Always do that. It makes life much easier. You don't forget what you've done before, and you can test. Okay, and here's the grammar. Here's the demo now. Now we're going to leave this presentation and call up the grammar. So let's move the presentation away. And what I'm doing here is I'm in a shell. So in order to run XLE, you should be in a shell. You should have installed XLE by now. I've already said that. One way to start XLE is to just type XLE. This should then work. Let me try to make this bigger. Yep. So if you just type XLE, then it'll say something like it's loading XLE. It's even bigger. It's loading XLE, and where it's loading XLE from. In my implementation, in my installation, it's in user local XLE. And it's giving you some copyright information, and it tells you what the version is. I'm running a version of 2009. The newest version is 2012, I think. The 2009 version is useful for the demos that I had, so that's what I'm running right now. And then you could do something like load your grammar in. You do that by saying create parser grammar1.lfg, for example. And then it'll say something like loading the grammar. It has 3 rules, etc., etc., etc. Okay. And you can now parse things from here as well. I'll just show you that. The dog devours bones. This is a sentence that works. And here is the parse. You get four windows. These two right windows won't concern us for a while. They're good for debugging purposes, but not for anything else at the moment. They show you ambiguities and how the ambiguities can work. They're also useful. Here's the most probable button if you have a statistical feature disambiguation file, but we're not going to use those. So we're going to use just these two windows. On the left is the C structure and on the right is the F structure. By default, the node numbers are turned on. You can turn them off. I'll keep them on for a minute. What you have here, the node numbers actually, they're randomly, not randomly, but they're assigned automatically by XLE. And what they're referring to is they're telling you where the information is gone. So bones here is 7, and it'll be over here. You'll see that the information associated with bones is over here in this part of the F structure. And you'll see here 4, the information of that is associated with this. Okay, so that's just telling you that. So to look at this analysis, an S consists of a noun phrase and a verb phrase. The noun phrase consists of a determiner and a noun. The verb phrase consists of a verb and a noun phrase, and you have these lexical entries. The F structure has as main predicate devour, a subject and an object. The subject is dog over here. The object is bone over here. And what we also know is mood indicative and tense present. Okay. One of the things that you can also do is if you take your mouse and you right-click on something like this, you get several options: show morpheme, show F structures. If you just do show F structures, it gives you just the F structure associated with that node. So this is the node over here, 18, and that's the information associated with that: pred bone, number plural, person 3. Okay. And you can do that for all parts. You can do that for dog over here, show F structures, and then we just have the dog. And you can go back to the top node and then you get the whole F structure again. So you could try that on your own. Okay, so now I've did this all by calling up the grammar from within the shell. I actually prefer, so if you want to get out of XLE, type exit. I actually prefer using XLE with editor of my choice. I use Emacs. So what I'm going to do is I'm going to load the grammar into Emacs. I just give the command Emacs grammar 1. You can do this in any which way you want with any editor of your choice. Just make sure you load up the grammar. And that what we have is an Emacs file. I will make that bigger too. Okay. And you will have, when you were installing XLE, you will have been told that Emacs comes with an LFG mode. You can see that here, there's an LFG button over here. And with this LFG button, I can do something like start a new XLE process. I'll click on that and it'll start a process. It'll do what it showed you on the shell. It's loading XLE from the place where it's installed in my computer. It's telling you the version, etc. And from here I can also do what I did before. I can say create parser grammar1.lfg. This is how to load the grammar into XLE. It'll do that, and it says I'm loading that grammar. It's got 3 rules, 9 states, 7 arcs, etc. And I'm ready now. And again, I can do something like parse the sentence. Dog devours bones. It's the same sentence we had before, giving you the same kinds of windows. Okay, so, and it tells you one solution, however many CPU seconds, 0 in this case, it was that fast. Okay. What I would like though is to work with a grammar file, with a test suite. So what I'm going to do is I'm going to call up my test suite. I'm going to put this into 2 windows and call up my test suite. And here's the sentences I want to show you. The dog devours bones, we've already seen. You can see in the test suite you can use this hash mark to indicate comments, and then you can have the sentence that you're parsing. And these are the other sentences we're going to look at, and to show you the different violations that there are. But before we do that, we will look at the grammar itself and have a look at that. So let's find that. Let's get a new. Here's a new thing. Let's find the grammar. Grammar 1. Let's make this big again so that we can see it properly. Okay. So, your grammar, grammar 1, consists of, these are all the bits and pieces you've already seen before. The name of the grammar, Demo English. This is the configuration file. We have rootcat s, no extra files. We have lexical entries, templates, and rules in the sections. They're all called Demo English. We have governable relations, these ones, allowing for different kinds of obliques. We have semantic functions, just in case we need them, pause, focus, etc. And this would be non-distributives are for coordination. Epsilon, empty categories, optimality order, we're not using that, but it's all there. The 4 dashes here to indicate the end of that section. We have some rules, Demo English, rules section. We just have 3 rules, remember it said that, loaded grammar with 3 rules. We have an S rule that says sentence consists of a noun phrase and a verb phrase. It's exactly the rule that we had in the slides. And the noun phrase is the subject and it's case nominative. And the verb phrase is providing the head of the sentence. The verb phrase in turn consists of a verb and the verb, a verb which is the head, up equals down. An optional noun phrase, and that's it. We haven't graduated to prepositional phrases yet. And then the noun phrase consists of an optional determiner and a noun. Okay, so we're very, very simple rules. We don't have any templates yet. Those will come later. But we do have a lexicon. And this works exactly how I've showed it to you before. So bones, noun, morph code, saying full form lexicon. And in this case, it's the plural version. Here, it's the singular version. And you can see with the comments, I've forgotten to add a pred value here. It really should say ups pred is equal to bone. I've forgotten to do that here, and I did that on purpose so I can show you what happens when you've forgotten to add it. We have lexical entries for dog versus dogs, one's singular, one's plural, and we have some verbs, devours and appears. The verb has a predicate. This one is a transitive verb, subject-object. This one is an intransitive one, just a subject. The other information we have, which is associated with the verbs that we've said present tense, we've said it's indicative. It's not clear this is the best place to put it, but we've put it here for now. And we've got subject-verb agreement. English has subject-verb agreement, and so we're saying in this case we know that the subject needs to be third person singular, and we've put that into the lexical entry. This would usually come out of the morphology. Here we have a full form lexicon, it's in there. This is worth looking at because I found that people don't understand the way LFG does subject-verb agreement or agreement in general. It's coming from the verb itself, and the verb is anticipating. It knows that English has subject-verb agreement, so it's saying my subject's person is 3. My subject's number is singular. Okay, this needs to be observed, otherwise the sentence will be bad. Finally, we have a few functional elements down here, the and a, just def plus and def minus. I see that's a mistake. We should correct right there because a is indefinite. And then we have these 4 dashes at the end again. Okay, so this is the grammar that we're loading in. This is the grammar that we've loaded into XLE. Let's move it away. And now we've already seen the dog devours bones. Now let's try to see what happens if we say the dog devours bones. This should be bad because this is ungrammatical because of subject-verb agreement. Okay, so let's see what happens. What I can do to parse this in order to save myself some typing is I can say escape. That's what I'm typing right now, and it comes down there in the XLE. You can see it there. Escape, then control, and P, and it'll parse it right away. Okay, and so what you see here is you see a tree. It's got a tree, but it's marked the S level here with a little box, and it's given you F structure. It's gotten a problem here. It says it's inconsistent. And why is it inconsistent? Because there's a feature clash, the numbers being specified as plural versus singular. And it says, well, I can only have one type of feature for a value. It needs to be a consistent feature, and here we have inconsistency, so something is bad here. What is bad? Well, devours, remember, says my subject needs to be singular third person. And dog says, this is the subject here, dog says, well, show structures. Dog says, I'm plural. Okay, so what you're getting inside here is a plural, and what you're getting here is a singular, and that leads to the feature clash up here. So if you see this kind of stuff, then you need to fix your grammar in some way. Or you say, okay, this is good because this is actually not a grammatical sentence in English, so I don't want to parse this. Okay, let's try the next one. This is a violation of coherence. The dog appears bones. Again, it doesn't work. It's ungrammatical. It gives you a little box over the VP. You can click on that and say show F structures. And what it tells you, it's incoherent. Okay, why is it incoherent? Well, appear says it needs a subject, but nothing else. But the F structure actually has found a subject. Well, it will find a subject, the dog. But it's also got an object it has to deal with. And this object is not licensed by the verb. It's not licensed by this main predicate. So the entire F structure is incoherent and therefore not good. And in fact, this is not a good sentence in English, so this is good that it's not being parsed. Okay, another one, the dog devours. Again, I'll put my mouse on it, go escape, control P, so I don't have to type it all. Again, no success in parsing. Why? We can click on this little box here and say show F structures. And it says incomplete. Incomplete, well, why? Because devours wants a subject and an object, and it doesn't have a subject. Or no, it doesn't have an object. So it's going to be able to find a subject, but it doesn't have an object. It says, I did not find an object. There's no predicate here. I cannot parse this sentence. And in fact, devours needs an object. This should be bad. It should not be able to parse this. Okay, and two more examples. The dog devours a bone. This is a good sentence in English. This should be able to be parsed by the grammar, but it isn't. So you think, okay, but I know this is a good English sentence, so what's going on here? You can again go on here, go on show F structures, and it says incomplete. I don't have anything for the object, and you think, well, why not? Look, here's an object here, the NP's right here, what's your problem? Well, you can go in and it tells you, I haven't found a pred here, so if you go and look at your grammar, at this point you have to go and look at your grammar, hopefully you'll notice very quickly that, oh, you have forgotten to add a pred value. And you can try to do that now. You can say, okay, I'm going to say ups pred is equal to bone, just like up there. Okay, save it. You have to save it either that way or save it over here, save as. Okay, save the grammar. And then try again. If you just make change in the lexicon, you don't have to reload the grammar, you can just try again. And the way you can try again is to just put your mouse over where it says parse, the dog devours a bone, hit return, and it'll try again. And in fact, now it worked. Okay, because we fixed that bug in our grammar. Let's try the last one. The dog devours bones in the park. You will see this a lot. This is not working. And it's also always useful to see what it says about why it's not working. So XLE will say, chart unconnected because of unknown words. Problem, word possibly causing problem, park. So you've got an unknown word in there. And in fact, if you look back at your grammar, we do not have park in our lexicon. We need to specify that. In fact, we also don't have in our lexicon. And this is what this morphology chart shows you. It tells you what words were found. The is a determiner, dog is a noun, devours is a verb, everything's fine, bones is a noun. In, no idea. The, idea again, that's a determiner, that's fine. Park, no idea. So when you see this this morphology window, what it's telling you is it's telling you two things. One, it's giving you information about which things it found, which words it found and which it didn't. And for another, what it's telling you is it did not find a C-structure rule. It did not find C-structure rules which could parse this. And in fact, if you go back and look at the grammar, we do not have C-structure rules for this. We do not have C-structure rules for in the park. Where's our grammar? Here. Okay, so first of all, we do not have park here. And secondly, we have no rules for PPs. There's no way we can parse something like in the park. So we'll add that to our grammar at a later point. At this point where I'm not going to fix the grammar to do that, we'll leave that for a different lesson. This is just to show you that if you're trying to parse something and you get this kind of window, this is an indication that you need to go and fix your C-structure rules and you need to add the information, information to your lexicon, okay? So don't be mystified by this window. This is what it's telling you. Right, that concludes the demo. Let's go back to the slides. There's only a few more slides left. Okay, so we've done the demo. And now we'll move on. One thing that Grammar 1 does not contain is templates. It contains C-structure rules with annotations, we saw that. It contains a lexicon, we saw that. It does not contain any templates. We're introducing templates very early on in the grammar development course because we found they save time in grammar writing. They encode linguistic generalizations very well, and you should learn how to do that early on. And they help in keeping your grammar clean and organized. So if you're making one change somewhere, you just have to if you decide that you're going to treat person in a different way or number in a different way, you just have to make the change once in a template rather than all over the place in your lexicon. Okay, so how do templates work? They're basically abbreviatory devices for F-structure annotations. They have to be defined in a separate section. We saw that. It's empty in our Grammar 1. Here's an example for a template. This is something that it's called pres 3 singular. You can call templates anything you want. What you say, so this is the name of the template over here. And you say equals, you're saying what this template is. So you're saying this is the abbreviation for this bit over here. What I mean to say when I say this is I mean to say ups tense is present, ups subject person is 3, ups number is 3, ups subject number is singular. Okay? So this thing, pres 3 singular, is an abbreviation for these three equations. And how do you invoke it? Well, you use the at prefix, something like at pres 3 singular. Okay. Templates are very good for expressing generalizations. In the lexicon, in the grammar, and within the template space, you can use them all over the place, and you should be using them all over the place. So here, right to the right is an example without a template. Something like girl is a noun. It has a predicate girls, number singular, definite. It should be definite, or it could be plural. With a template, what you can say is, okay, I'm going to define a template CN, stands for count noun. I'm going to say, okay, count nouns in English are either singular, and if they're singular, they have to be definite. This, there's no equals here. This is an existential equation. I'll talk about those in the next lesson. It says, basically it's saying that it has to be definite. Or, if it's not definite, then it is plural. So you can say a girl, the girl. You can't just say girl, but you can just say girls without a definite article in English. So then what does your lexical entry look like? It looks like something like this. Girl and predicate girl, and then you call up the template at count noun. So you don't have to type these three equations in anymore. You can just say at count noun and save a lot of typing time. And if you decide that count nouns in English actually works differently, or you want some other information, then you just change it once in this template. You don't have to go and change it every time in all of your lexical entries. This is a big advantage of templates, which is why you should be using them right away. You can also use templates in a different way. You can parameterize them to pass in values. So you can say, well, look, I want the pred thing, that's going to be the same in all these count nouns as well. I want that in 2, but in fact, the value of the pred is going to differ depending on what it is, whether it's girl or boy or dog or bones. But I can have a variable, I can introduce a variable, p. So what I'm saying here is I'm a template and I'm allowing for a variable p, and whatever this variable p is, whatever the value for this is, that should be put in here as the pred value. Okay. Then your lexical entries look like this: girl, noun, at count noun, call up the template, give it a value for p, girl in this case, boy in this other case. And then you'll end up with girl for girl and boy for boy. Okay. What you can also do is you can call other templates. So you can define templates for intransitive verbs, for transitive verbs. And then this happens a lot in English. You have a lot of verbs which are optionally transitive. And you can say, okay, optionally transitive verbs are either intransitive or transitive. So you can ask for both those options. Okay. So we'll work more with these templates, more and more and more. A note on templates, using them makes it possible to create an inheritance hierarchy of lexical entries or of rules, etc. But nothing in LFG or XLE forces you to have an inheritance hierarchy. And this is different if you're interested in HBSG. HBSG works a lot with inheritance hierarchies and it forces you to use them. We can use them, we don't have to. And in practice, we found that we have template calls up to a maximum embedding of 3 levels and not more. Otherwise, it starts getting to be too confusing. Okay, I'm not going to demo templates as part of this lesson. What you will do, though, is you will go. So the practical work at the end of this lesson is going through the XLE walkthrough. It's part of the XLE documentation. There's details on where it can be found and exactly what you should do in exercise 2. The walkthrough is extremely informative. It's very thorough. It gives you a lot of background. It goes through some of the stuff I've done here again, guiding you through it step by step by step. So do it and be prepared to spend some time on this exercise. There's a lot of reading involved, a lot of entering lexical entries, making templates, experimenting with the different types of templates. So this is what the practical work is at the end of lesson 2. And that's it. And next time, lesson 3.